the afternoon sessions right after the excellent keynote that was a little bit before. I have a topic that might look a bit different in the landscape of the conference because it's a combination of many technologies that we used in the past year to deliver a product that we're using in-house, and sometimes our customers want it. So because we didn't find like a proper name, naming in development is like the most hard thing to do. So we started with John Doe, and it ended up as Johnny. I know it's not the ideal name, so if you find a better one, feel free to come over and come up with a better idea than we did. A couple of words about myself. Maybe you've seen my talk yesterday about how to train your minions. Another very interesting thing that we like to do at our company and for our customers. So first of all, I'm not a web developer. I started doing web development and then later moved to applications more than 15 years ago. It's quite a long time, and I wanted to give up the stress so many times and pick something more easy to do. And then every time I come back with new ideas and fresh technologies. So I myself am a minion for the past 15 years. I never stop learning. I recommend you do the same thing. So in the past 7 years, I specialized into, it's not a niche, but it's a very tricky place to find work into, like working on large-scale applications. And when I say large-scale, I mean $10 million a day transactions, that kind of stuff. So this is where I come from, and I title myself as an architect for the past 7 years, but what I mostly do is I hack systems. So I make them do what my customers need them to do. Last but not least, because of attending so many successful international conferences, I discovered that my own Romania doesn't have one. So we started one last October, and in a couple of weeks we'll have already our second edition. If you feel like traveling to Romania, please do. It will be super fun and interesting. And as I said, because I like to hack a lot of things, I also discovered that doing a PhD in AI sounds like a very bright idea. So part of this talk is coming from applying some of the lessons that we learned there. And mostly the data collection is actually a result of my beginning months in my PhD. For you to follow better at home, I actually prepared a code base. You are free to download the code. It's a Dockerized version that contains all the necessary tools to get you set up and all of the sample codes that you will see in the later slides. And additionally, because we are using Jira, we have a Dockerized version of Jira. So in order to perform the actual setup of Jira, I also prepared like a very small YouTube video. Initially, it was like an internal training for us because we communicated the steps so many times and figured out that maybe a 3-4 minute video is a much better idea. So feel free to use that one as well. In order to talk about any kind of chatbots, I believe that to structure the presentation, a better idea would be to actually look into how chatbots have come to life and what is the current state in 2018. Then I will introduce the architecture of our bot, Johnny, and then we'll have some demo videos at the very end. If the time allows, we'll also have some questions. If we don't have enough time, feel free to grab me. I'm here all day today as well. So when we actually look into chatbots, did you know that the first chatbot is not something that appeared like 2 or 3 years ago, but appeared in 1966? That's quite a long time ago, and it was actually created at the MIT Artificial Intelligence Laboratory. It started as a pattern matching tool, and later on, in time, it grew from an academia perspective to a more production-ready perspective. So come 1993, a very interesting milestone is AgDrop, which is in fact a combination of TCL scripts, C modules for the IRC platforms to help administrators do more user management and channel management tasks. So this is something that was already production ready. And in 2011, also quite a long time ago, but not that long ago, on AOL, now defunct, instant messaging, there used to be a real chatbot. So Smarter Child was the first chatbot that resembles what we do today in terms of chatbots. And it's such a shame that it was on a platform that is not used anymore. If you want to start your journey into building bots, I think a good idea is to go through the bot directories and see all of the weather chatbots, all of the boring ones, but also discover some hidden gems. And here I have like a short list of places where you can start from. And the last one, Chatbots.org, is something that I'm using to, as a reference to see how many platforms are people using when they are writing chatbots. So you can see it's not only what you would assume, like Facebook chatbots or Skype's like chatbots, but there are a lot of things that people have chatbots for, and we don't even know they are writing them for. So quite a very interesting place to go. So let's move on from the boring introduction part to the more interesting developer-oriented ones. So if you are to start writing a chatbot, what would you need? First of all, you need a user to communicate with a certain level of a conversational interface. And most of the time, your users will perceive that conversational interface as being the bot, but it's only like the front end in a normal traditional web application. Because all of the processing that's done in the background is the actual complicated part that you will need to build. And in order to address those many platforms that we looked briefly a couple of minutes ago, there are some bot frameworks that you can use. The trick to using a bot framework is that the way messaging works with a Facebook application is completely different from the one that you would use on Twitter or on Slack. And so on. So when you use a bot framework, what happens is that the message that the bot framework will interpret will have the same structure. So this is what it does internally. It aligns all the inputs and outputs into a certain level. In our case, we chose Botmaster, and what Botmaster does is translates everything to the Facebook structure of messaging, and other platforms use, of course, their own version. There are quite a lot of them. And the important thing about a bot framework that you need to remember is that it's not a very complex piece of software. So other than doing the translation, it will just communicate all the information to your background processing code. So I picked a code sample from the Botmaster website just for you to see the multiple platforms that it can already interact with out of the box. So you just install it, and you can already do Facebook messaging. It doesn't say Facebook, but the messenger bot is the Facebook one. It knows how to communicate with Slack, Twitter, and Telegram, which are the most used and nowadays. So I think in the past year, I personally delivered like 7 or 8 projects having chatbots. And this way of standardization really helped me focus on the background code instead of communicating with all these platforms. A very interesting one that I want you to see is the socket I/O. So not only you can grab information and communicate it to various channels, but you can also have a socket I/O connection, which is very useful when you want, for example, to have like an administration interface to watch the status of your command. You can just push the data to the socket connection and deliver it in that way, in addition to people interacting with the traditional channels. So very useful. And if you want to have a look on how it's used, it's quite simple. You just instantiate a new Botmaster instance, and then you add the bots that you want, the communication channels that you want your bot to talk to. And you have a couple of settings for each of them. And in the end, your Botmaster instance will be able to talk to all of these channels simultaneously. So the good thing is that you only have like one brace, and all of the communication channels will be transparent to you for the same instance. So you don't need to write a bot for every platform. Very, very useful. Now, what does our Johnny the Deployer do different from other bots? If you looked in the Slack directory or in the documentation, you probably discovered that you can write a Slack bot in a much simpler manner. You just have a standard command, and once your message starts with that standard command, everything else will be passed as parameters to that bot. Now, that is a very useful beginning scenario, but we are in 2018, and people love natural language. So in order to interact in a natural language manner with your bot, you cannot use those tricks. As a matter of fact, our Johnny bot started life in 2010. As a Skype bot that was doing exactly the same things, but it was very difficult to use by project managers and by QA people because they needed to remember all of those command formats and so on. And that is why we now have a natural language part. So how do you actually deal with natural language processing? Well, in addition to grabbing the data from the communication channel, your processing part, which I call the brains of the bot, will actually talk to an, in our case, IBM Watson service that will do the NLP part, and then it will give you back the intent of the user. So what was the user actually saying? Now, the good thing about having a backend piece of code that would communicate with an NLP service is that you can very easily replace IBM Watson with API.ai or with Dialogflow and other things. So it's, you don't get tied to a certain NLU provider. And another mention that I really want to make at this point is that there are two different options. One of them is to use a cloud-based version like Watson and Dialogflow for NLU. But if you want, if your customer has the requirement of doing the NLU in-house, there are certain platforms, and one of them is actually based here in Germany. It's called Rasa. So if you use Rasa NLU, you can actually train models and install them on premises using this exact architecture. So you just replace Watson with Rasa, and it will automatically do what you need in terms of NLU. Now, I want to give you a warning. NLU is expensive, training the model, so you really need some hardware or some other means of doing the model training. But once you have the model trained, then the actual NLU understanding is fast for the customer. So the only heavy, expensive part is the model training. A piece of information that is not very well known. Maybe you believe IBM Watson is coming from the famous detective stories. It's not the case. In fact, the first CEO of IBM was called Watson. So this is how they named it. And when you say Watson, you are in fact talking about a large collection of AI technologies, AI and ML machine learning. So it's a very generic term. In our case, we used Watson Conversation, specifically designed for chatbots, but it's only useful for quite simple flows. So if you have a very complex flow in your dialogue that you want to cover, the stories become more and more complex, then you have the possibility to move to Knowledge Studio, which performs this task better, let's say. So there are various solutions that you can choose. There is no right way, of course, like in any software project. And I have a couple of screenshots from Watson Conversation to help you get started. So we have the term of workspaces that we work with. And they already provide a very complex one, the car dashboard. And then any of the workspaces that you use will have a unique identifier, and this is what you need to plug into your code. And I'm not sure how well we will be able to see this. This is the car dashboard example, which is very useful to learn from. So you can see it has a lot of intent, trying to reveal what the user has said. And in here, the number tells you how many samples they gave to train that particular intent. So you can see the capabilities has more than 100 examples. The more examples you give it, the smarter your bot will be. A trick about using cloud-based versions is that they not only use your supplied intents, but they also have the collection standard one that they add to your knowledge base. So it's not only 100 examples. Whereas in the case of NLU models that you train yourself, you have to give every individual example. That is why the training takes so much longer. So cloud-based versions actually use a lot more examples, and that's why they are look much smarter, because the training set is much wider. And you can see that for every, in our case, one of the intents is how many tickets do we have already for testing for QA. And we are just giving like 5 or 6 examples. And this is already a good enough start for the bot to understand what's going on. And in Watson Conversation, you have on the right-hand side something that you can already try out. So you can do trial and error training until you get it the way you want it to be. This is, in fact, a video demonstrating how you can use the tryout. So if you say, what can we test, something that we never had here, it already understood your intent and it will reveal it. And when you talk to Watson Conversation, it's a JSON-based conversation. So it will send you the relevant information in a JSON format so you can depict your intent. But this way of showing you the interface is not as interesting as showing you the final demos, so we'll save the time for that. I want to walk you a little bit through the architecture. Architecture is a very fancy word, but let's use it for now. So it's more of a diagram to help you figure out what are the moving parts of the system and where you can interact with. So in our case, a teammate asks a question to the bot, the conversational interface that we discussed previously, and in the end, we'll receive an answer. This is what your end user sees. This is what my project manager sees. So what happens under the hood? Well, the bot discusses with server-side code, the brains part, to try to figure out what the user has said, so what is the meaning, and compute the answer. Now, in order to do the NLU part, we go to Watson and say, what did my teammate actually mean, and extract the intent. Sometimes you also match entities. So you will see in the next example that entity is, in our case, if you ask the question, when was the last deploy of the CMS to QA? QA, that value is the instance of the environment entity. So the environment is QA, or it can be staging or production and so on. Once we have the NLU figured out, then we can go to Jenkins. If we did our build with Jenkins, we now do it, of course, with GitLab. So we go and interact with the GitLab API to find out that information from the runners. And then the unprocessed data arrives in the server-side component, in the brace, and then we can do data processing so that we can compose a decent answer to the end user. So you can see here all of the stack that we are using for a very simple DevOps chatbot. It looks quite daunting in the beginning. It feels like playing Lego. So if you're going to build a customer-facing chatbot, you will need to have a lot of sessions to train the NLU part, because you want your bot to not do bad things like the Microsoft one that some people manage to learn it how to swear and other things. So you need to be very restrictive with what it can do, but also with what it cannot do. So the other components in our case would be Jenkins or GitLab and Jira to extract the information. So now a couple of informations on how to set up Slack chatbots. So it's quite simple. You need to create a Slack application in the API version of the website. In our case, we have the company Workspace, and it will. You need to pick up these two tokens and set them up in Botmaster. Then, for a demo, I'm using a ngrok version of the bot, but you will need to provide the hook that Slack will send the data to, and enable the events that you want your chatbot to understand. So you don't want to receive all the events that are ever happening in the general Slack channel, for example. So you only want the IAMs or groups ones. Depending on your needs, you can set up different events that Slack will send over to your hook. Moving on to the more interesting part, where we get to see some code. Botmaster, as I mentioned, it's the part that is translating various communication channel messages into one standard format. So in our case, to set up a Botmaster instance that's connected to Slack, we need to set up a file in Slack Teams info with a certain team identifier that you get from Slack, and then the bot user ID and the SS tokens that we picked up in the previous screens. So it's a configuration-only way. It's not something very complex. You can get it up and running in like 5 minutes. And the actual application that is receiving the messages, you see here how we set up the Slack bot and attach it to the Botmaster main instance, and then we provide the credentials coming up from environment variables. So this is a very easy way to, if we, for example, want to add more channels, more teams, it's very easy to deploy this piece of code because it's just very, very simple to configure. And in Botmaster, you have two means of addressing. One of them is incoming messages, and the other one is outgoing messages. So in our case, we just need to handle the incoming messages. So we listen to the request, and then forward the actual text that the user has inputted. We forward it to the brains component, and then act on the response. So if we don't have a 200 response, we just say that there is something wrong. But other than that, we compose the response. So as you can see, the first part of the bot is not a very complicated one. In here, you can see how we test it. So we just supply the user message, and then we receive a text version that we are going to display in the Slack channel. If you deal with multiple channels, you will need a bit more code in this part. Moving on to the brains part, this is a very simple and nice PHP application, so nothing fancy. I actually I'm showing the structure because I think it's easier to explain. So we only have one conversation controller that receives the message from Botmaster, and we have three different services for this example. One of them is ask, which goes to Watson and grabs the information. The other one is execute, communicate with Jenkins or GitLab. And the other one is task tracking, so go to Jira and figure out things from there. So if we want to look at the code, how this communication is performed, it's quite simple. We deserialize the request into an entity, and we have an exception listener. If the information is not properly deserialized, then we go on the fallback track. If we didn't receive any kind of message, very simple error handling, and then we get the ask service instance from the dependency injection container and execute the ask method, which goes on and talks to the NLU component. You can see here if no intent was discovered, so we didn't figure out what the user's message, how it translated to an intent, then we can also handle that case. Because if there is no intent, then of course our bot doesn't understand that particular text. So this is the place where you do the more nice processing of how you communicate with your end users. The fact that your bot wasn't prepared to answer the question that they had. And because I'm showing you like a trimmed down version, it's like a demo version of the code. This one only has like 3 intents. We of course have about 20 intents at the time. So ours looks more complex and is not a switch-based code. But in this instance, you see that based on the intent, you go and execute a certain method that does what you need to do. So let's take, for example, the second case where you do a build and deploy. This is how we package all our code. So we say, please build this component, the CMS or the API or some other component, perform a build, and it will trigger a Jenkins build where we actually pack the RPM or deb package. This is the standard way for us to deliver the code. And then once we have the RPM and it's declared in the on the server side, then we move on and do maybe an installation or not. So we have not. That's why I said we have a lot of intents. In some cases, we only need to prepare the build. In other cases, we need to prepare the build and deploy or chain those methods. So sometimes we need to control the actual deploy step. Quite easy. So if you were wondering how exactly do you communicate with Watson, as I said, it's a very simple JSON request and response. So what we do is prepare a request based on the question. And with that serialized version, we go and perform a post with all the authentication tokens taken care of in the Watson service. And then get the response, deserialize it into a entity, and then from there on we can actually count how many intents were there. Because if your bot matches 2 or 3 intents, then you need to pick the one that has the highest level of probability. And this is something we'll see a bit later. So I actually think we don't have enough time for Q&A. So these videos, I don't think we have time for them. I will try to show you the first demo because it's more interesting. So let me find out which one it is. This one. So the first demo is going to see how many issues in the development team are ready for a certain environment. In this example, the QA. So you can do some small chit chat. You say hi, and Johnny will respond with a different sentence every time. And then you ask, do you have tickets ready for QA? And what happens is that at the moment, we don't have any issues in the testing queue. You can see here the board that I'm using as an example. So once I'm moving a ticket to the ready for QA column, which is the actual query that I need to perform, and now I'm asking a different kind of question. Are there issues ready for testing? You can see that we have a list, and we even made it with links, so it's clickable, so that the project manager can immediately go there. So now if we move the other one straight to ready for QA and try using a different sentence, what ticket are ready for something. So every time you use a different way of formulating the question, and it will match the intent. You can see that both issues that you see in the background in Jira are now displayed. Okay, so this one we can, in fact, close. Another very interesting example that I want you to walk you through is the... right, so first I'm cleaning up the Slack history because it's going to get too crowded. And then this is the build and deploy part. In this demo, it's one single step, performing the build and executing the deploy. So when we say I need you to build an RC, a release candidate, for the CMS and deploy to QA, this is an asynchronous message. You never know when the build is going to end. So you just say, yes, I started the build process. I understood what you wanted, and I started the build process, followed by a deploy. So if we go now in Jenkins, we can see that the correct build was triggered. And here I have some random failing jobs, so that some are working and some are not working. If you don't use RC and just write build a new release candidate of the front end and deploy it to integration, you can see that Jenkins is coming back and saying success. It was a very easy one that didn't take too much time. And you see that the parameters were correctly instantiated. So we just have one Jenkins job that does all the builds. And in fact, in production, what we do is dispatch other Jenkins jobs for the specific environment with the actual code that's needed to build the RPM. So this one is a random failure for a demo. And you can see that also it picked up the component as front-end and the environment as being QA. If you want to get very risky, you can deploy to production in this way. And this is something that 2 of our customers actually do. And they don't feel like it's risky anymore because the entire deployment process is very streamlined. So let's see here. Again, the next build. Would you actually have the courage to do this in production with your code? allow your manager to just say, put the latest thing in production? No. Okay. Well, we do. And now the last example that I wanted to show you was, you know, Jenkins is a very tricky interface to navigate into. So if you need to go in the history and discover when something happened, it's not very nice. So this is why we have the query. Okay, so we just set up the demo. We perform the deploy. And you can see here that, so I'm picking up the response from Watson because I want you to see the confidence level that it had, that it matched the right intent. So if we just look at the JSON that it sent us, you see the confidence level is 0.92. So 92% confidence that it got the right intent is a very good one. You can put some thresholds. So if you don't want to execute intents which are lower than 80% match, you can discard those very easily. So now when we ask when was the website last deployed in staging, we just go and query the Jenkins API. We extract a very long JSON and go and find out the historical information in a much more meaningful way. And now here, I think I have an example with a lower confidence level. So if we ask something that wasn't trained, you see we only have like 4 training examples. And this is not very good. You need a minimum of 10, but I recommend doing 20, 30 training examples. You see it's just 0.54. So 54% confidence is not very good. You may not want to execute that intent. And another question would be also not matched in, so we don't type the exact sentence that we used for training. I want to know when we refresh the API in QA, or when we did the last deployment of the CMS in production. This is super useful in meetings. I can tell you that our project managers are using this feature the most, because they can find out relevant information without going to the technical team at all. And it's just scraping the history, and they can find out who did what, when. And for the geeks in the audience, I'm showing you the Jenkins API call that we executed. And you see this is a very, very long JSON. And we are discovering the last execution, successful or not, by identifying the right parameters. So the previous questions was with the queue environment and with the CMS component. And this is how we grab the timestamp and just display the information. So very, very simple from a customer perspective. And remember, this is just a DevOps chatbot. It's not a customer-facing one. So our customers are our teammates. So more examples of that. And we even access and prove the correctness of the query that we executed. Okay. So if we are to do this, we looked at the extraction, build and deploy, and query history. So thank you very much. I think we have enough time for questions. So I'm all ears. Did it look complicated? Would you feel confident to go home with this tech stack and build your own bot? Yeah, a couple of smiles in the back. So when we first started working with chatbots, things weren't as easy as this, you can imagine. So we fought all the alpha and beta bugs. But right now, the conversational interface market is much more stable. And there are quite a lot of requests for this kind of products, even for other things than DevOps. So we do a lot of conversational interfaces on grabbing users' preferences about who knows what. And we get to ask them a lot of questions. And the natural language understanding part is the one that does the wow effect, because you can actually relate to the chatbot before handing over the conversation to a person or to an email chain if the bot's knowledge is not that complicated. I will have to come over to understand the question. I apologize.
Did you have any cases where something went wrong? Something got broken for the customer side?
Not really, no, because this is just doing, this example in particular is doing builds and deployments, and we really tested our build and deployment strategy. So we didn't invent that one on the spot. It's just building a UI on top of it. But for customer-facing bots, customers ask all sorts of crazy questions. And it's very difficult to figure out the intent. That is why I was mentioning that you need a very good training set to actually figure out the meaning of what was said. And I can recommend you to perform more testing than development for any given chatbot. Because the impression that you leave on the customer is more important than giving an extra piece of functionality. So if you screw up in the communication part, it's more painful than screwing up of not having a certain feature implemented. You're welcome. Any other questions? How do we test? Bot? So first of all, we test the intent matching in Watson or in Rasa. So for deployments that happen on premises, we are using Rasa NLU. And we develop scenarios together with the customer to cover all the happy flows. And then all the negative scenarios, we try to figure out what can go wrong. So it's double testing. You have to have like a positive hat and then a destructive hat. It's very difficult as a developer because you tend to only code the happy flows, but you need to test very, very heavily the negative parts. And if you use a cloud-based NLU version, it will know about swear words and other complicated things. If you do your own on-premises model, you will have to train the model to understand that the customer is saying something bad. But you need to handle these scenarios, negative ones as well. So it's quite a lot of scenario writing, resembles behavior-driven development, but it's completely different. And you need non-technical people. If you don't build a technical chatbot, of course, you need non-technical people who are very familiar with the domain to do the training in a correct way. Okay?
Did you try to put the voice in front, so the voice commands to a chatbot?
So the question is, did we try to put the voice as an interface for the bot so that somebody can issue voice commands? This is something that we are, in fact, working on. So we have an API that does voice understanding. And the catch is that we need to have a proof of concept for a future contract. So we looked into more into better solutions for this. Just using an API is not always doing the trick. So there are some very good libraries, let's say, that you install on your mobile device, and it will do the recognition, voice recognition and transcription to text on the device. So there are solutions in the market. I cannot show you one. I know it would be the most impressive demo, but I don't have it right now with me. It is possible and doable, so you can play with it, definitely. Yeah. So the question is, does the bot only understand English? Yes. At this point, it only understands English because we are an international team, so we don't need to work with other languages. But if you train your models, so you don't rely on cloud versions, you can train them in your language. So the RASA NLU pipelines are highly configurable, and they use all sorts of stemming. So you can adapt the build pipeline to your language so that it provides maximum results. Okay. If you have further questions, I'll be right outside, so feel free to grab me. Thank you very much.